So yeah, let's start with our session. So today I'll be telling you about the specific operations you can perform on a data frame. So before performing any task, what you need to do is you need to import all the necessary packages. So till now, till the part we have studied, it is sufficient to import only these four packages. Even we haven't used Seaborn as of now, so we will be using it in the future sessions. So you need to import. So yeah, you need to import pandas, you need to import numpy and matplotlib. So these are all the necessary packages you should import. So what you should remember is like how in exams you like give the margins for your white answer scripts and everything. So likewise it is mandatory for you to do this importing before you start any of the data visualization or data analysis. So once you import all this, so what I'm trying to do here is I have imported a video game sales CSV file. So this class today will be for only a couple of minutes. Just so yeah, it's recording. So yeah, so our CSV is on video game sales. So what I have tried to do is I have uploaded the CSV file and I have copied its path, and then I have used the pd.read CSV method, and what it ultimately returned is, so yeah, I have stored that entire CSV dataset into a variable called as data frame. So when I wanted to know the type my data frame has, so it returned me that it is in pandas.core.frame.dataframe. So it basically means it is in a data frame type format. And the next is I want to know the shape, like how my data frame has been distributed in the rows and the columns. So I use df.shape attribute. So it has returned me that it has 16,598 rows and 11 columns. So I wanted to know what those 11 columns are. Like I want to know the label names of my columns. So that can be done by knowing df.columns. So that returned me the rank, name, platform, year, genre, publisher, the sales, and the sales in other market, and these all the different types of sales in different countries. So this total should be a total, these all should be having 11 columns. So 1 2 3 4 5 6 7 8 9 10 11. So you will get all those 11 columns, the corresponding label names. And next I have checked the index. So since we have checked here for columns, so people could ask me what it is with the rows. So rows are seen in terms of indexes. So when I did df.index, it has written me the starting value and the ending value with step equal to 1. So step equal to 1 actually means the difference between two corresponding row indexes. Like this is 1 and this is at 0. So 1 minus 0 is 1, that is the step 1. So if you take 1 and 2, so 2 minus 1 is 1. So that is the step 1 here. So range index is a constructor. So there is nothing for you to know much about it. So if I want to know the first 5 elements in my data frame, since I have converted it into a data frame using this pd.read CSV, so when I give df.head, so it returns me the first 5 values in my data frame, in my data set, in a data frame. It returns me the first 5 values in the data set as a data frame. So there you go, you have the rank, you have the name, you have the platform, which is Wii, Game Boy, PC, PS4, whatever it is, and the year which it was released, the genre, the publisher, and these are the corresponding sales values. So this is done by head method, so tf.head. So if you don't want to use that, and if you want to use the slicing, so it goes like this way. So I have used iloc, which stands for index based. So I have used this function, which means that till 5 elements, the first 5 elements, I want to print all the columns. So this goes like this. If you want to use the variable name, the label names, so you can use df.lock and give these all names. Okay, so the next will be going from the downside, so that is done by -5 because the negative index goes from the downside. So for that corresponding thing, you would be doing df.iloc -5 to above, and I want to print all the columns. So that can also be achieved by the same by using df.tail. So this is a contrasting thing between df.head and the iloc, which is done by slicing. And if you want to do by using the indices, you can do in this manner, or you can just go with df.tail. I have told you this only to explain how it works, because you should be knowing how slicing works in a dataset. But unlike, you can directly go with df.head and df.tail. So the next would be df.info. So it gives you the data type of each column and the number of null entries, non-null entries. So null entries actually means that this is a data frame, right? So what happens is some values will not be filled, like there will be a vacancy or a void in that particular place. So what we try to do is we either uh, take the values based on the mean. So like we will calculate the entire column and we will replace that missed value with the mean. Or what we can do is, if the values are close to one another, so then we will be replacing that above value. Like let's say this is 0, this is 0, and here it is, there is some void, and this is 0.01 and this is 0.00. So since there are like 4 majority things around 0.00, so what you will do is you will be giving the value as 0.0 here. So likewise, those will be a bit of a manipulations which we will learn to do in the upcoming sessions. So you should be knowing how you can handle null values also. That is the very important part. So df.info gives you how many non-null values are there. So all the values, there are like 16,598 rows, right? So all those values are non-null, which means that there is a value in every place, like nothing was left empty there. So it is giving you what type of data type that whole column is. So rank is in integer data type, and the next one is in object data type. The next one is float. One thing you should be remembering here is the int and the float data types are called as numerical columns, whereas the object data type which you see is a categorical variable. So what happens is you cannot, so if there is a missing value here, so you can't replace it by mean or something, because it is not some numerical thing going on there. So yeah, if it is a numerical column, let's say since this is a numerical column, so if at all there is any missing value, you can replace it by mean or something. But in case of a object column, which is a categorical column, you can't replace, let's say racing is missing in genre column, so you can't replace something like with mean or anything here. So at that moment, what we will be trying to do is we will be ignoring this whole row. So you would be pulling off this whole row from the data set. Since like there are 16,000 some 598 entries, so removing one row actually doesn't affect your analysis. So that's how, like whatever you do, it is based on your assumptions and your understanding of the data set. So what you present before your manager is your understanding on how you perform different analysis on the data set. So each analysis varies from person to person. So that thing you should be aware of. So yeah, and you can see here that in 1632 327 there are like several null values, but what they have done is they have tried to put it with some value, like some random value. So we will we will be knowing all of this in the future sessions, like how they have been replacing the other null values and everything. So what you should be knowing for now is df.info returns you the type of data for each column, and it gives you the total number of entries, whether be it a null entry or a non-null entry. So once you are done with df.info, the next would be df.describe. So df.describe gives you all the statistical analysis, like the mean, it gives you the standard deviation, it gives the maximum value, it gives the minimum value, and it gives you the quartile ranges as well. So 25%, 50%, and 75% quartile ranges. So you would be getting by using the df.describe method. And one thing you should be noticing here is it will not be giving any mean or median or standard deviation for object variables. Like you will not, the name and platform is an object data type, right? So you will not be seeing name and rank, name and platform here, because those are categorical variables. They don't have any numerical values in them. So you would not be seeing them. You will not be able to calculate the mean and median there. So this is all which you should be performing. Like this is all the thing. These are all the things which you should be performing when you import a data set. And in future sessions, we would be learning about the dot drop na method, fill na method, and everything. So whatever you do, just make sure that you perform all these operations once you import a dataset. So what happens is you will get an understanding of how your dataset is, how those values vary, what are the type of data, what is the data type of a specific column. So you will be getting a basic understanding of all those. And the next would be, so that's all for today's class, like till the describe method. And now we will be learning about how we import different types of files. So what we have imported here is a CSV file. So we have used pd.read CSV. So there are like so many files, right? They are not only CSV files. There will be some .txt files, some strata files, SAS files. So we will be trying to understand how we can import different type of files. So the first one is the flat file. So flat file is basically categorized into .txt files and .csv files. So .txt files is something you can see in day-to-day life, like if you take a notepad or something, so it gets saved in .txt format. So .csv stands for comma separated values. You can know its structure. You can just Google it online and you can see that the whole values will be kept in comma wise. Like let's say the name and platform, they will be separated by a comma. So the whole data set will be like rank comma name comma platform comma year comma genre comma publisher comma. So it will be in that format. So that's why they have been named it as a comma separated values. So yeah, whenever you try to read a file, the first and foremost thing which you should be doing is you should be allotting the path. So likewise here, what I have tried to do is I have given my CSV file. I have taken my CSV file and I have took its path, and using that path I have read the CSV here using the pd.read CSV. So what you are trying to put here is the location or the path where your CSV file actually is. Okay. So yeah. So this will be the path. It is not the file name, so don't get confused. It is the path where my file is. So I am taking that into a variable called as file name, and using this is the general syntax which you can use. So you can replace this r, which where r is used for read, which can be replaced with w, which means that you can actually make a changes to it, like you can write the thing. So I have taken a sample.txt which contains this message. uh, So the thing is file equal to open file name, which I have given here previously, which contains the path of my sample.txt, and I have used the mode as R, which is just for reading. And the next part which I have done is I have done it file.read, and I have closed this. So when I try to print the text, because I have given it correspondingly the read method, right? So when I try to print the text, it would return me this. But the whole general part of this like the problem with the syntax is, unless you don't write this file.close, the whole program will be returning an error. Like if you don't write this file.close method here, so the program will return an error. So instead of that, what we try to do is we use a context manager. So that will be as simple as this. So what we'll try to do is with open, this is the location where your txt file is, and R as file. Just listen once again. So what you're trying to do is with open, you are giving the path location, and what you're trying to do is you want to read the file. So you would be writing something like with open my path location, which I want to read as a file, and you will print this method which I have told you previously, file.read. So you will directly do print file.read. So that in turn returns you this. You no need to like print this file.close. Like what happens is this method is also feasible. Like you can use this method also, but it is mandatory that you should remember that you have to write this file.close method every time. So if you don't write it, it would return you an error. So instead of doing all those, our this syntax form is called as a context manager. So it would be simple. You will write just like with open my path location, and you want to read it as a file. So you will directly print it as print file.read. So that will return you this. So this is how you read a txt file. And the next would be a CSV file. And as you know, the CSV file is read by using the Pandas library, Pandas package. So you can use this method pd.readcsv, like if you are not clear with it. So you will give a path where your CSV file is, and you will use that path and put it here. Like you would be writing pd.readcsv with the path you mentioned, and you will be assigning it to another variable called as a df. So I have taken df stands for data frame. So likewise I can perform operations using this variable. So I have used like that variable directly. Instead I can also not give this thing and write pd.readcsv path, and for everything I should be writing like pd.readcsv path and dot shape. So that is much of a hectic code. So instead of not putting it into much complexity, I have just taken like df, and I have used this df.shape, df.columns, df.index wherever I could. So that is how you read a CSV. And again for the text file, so this is all a bit of a complex thing. So what we'll try to do is we will be using context manager from here. We will be using like with open, you want to open the location of your path, the location of your text file, and you want to read it as a file. So the next thing you would be doing is you would print the file. So that can be done by print file.read. Categorical can be replaced by mode right, most frequently occurring data. No, categorical variables is actually string. So let's say your name is Lakshmikant, and here there is Ramesh. So if there is, so let's take Prasanna Kumar Reddy and Lakshmikant, okay? And in middle is the name person called Ramesh Gunda. So I don't know Ramesh is there. So there will be a void value here. So I can't add both of your names and keep a mean here in Ramesh place. So that makes no sense in adding two strings and taking a mean for two strings. So it is just not right. So what we will try to do is in future classes, we will be replacing it with something called as dummy variables, which will be in the strings will be converted into binary values, either 1 or 0. So you will be knowing much about dummy variables in the future sessions. So categorical variables cannot be replaced if there are string values. So categorical variables can be replaced only when you convert them into a dummy variable, and that dummy variable can be used like how you said, you can use that replace by mode or mean or something. Yeah, so this is the sample.txt. So this is how you read a txt file using a context manager. So the next would be the read CSV. So you will use Pandas for reading a CSV file. And also there are several different types of files like Excel spreadsheets, MATLAB files, SAS files, which stands for Statistical Analytical System. And next is this data files and HDF5 files. So HDF5 files are actually used for like by NASA people. Like the data is like so much, right? All the video clippings and all, there are like huge chunks of data. So those all types of heavy data will be stored in HDF5 format. So yeah, here is one thing called as the pickled files. So that is another type of file format. And also these from now on what we'll try to do is I have like written everything in terms of a context manager. So a pickle file is another native file type of Python. So what happens here is they are serialized, like the values are arranged in a series format. So serialized is nothing but everything is arranged in a series. So if you have encountered with a pickle file which usually ends with .pk1 format, so what you will try to do is you will import pickle and you would perform the same with open, which is your file. This is your file location ending in pk1. Like if it is a pk1 file, you would be giving the location where it is. What you are doing here is read binary, which is a normal thing, it is a reading, and you would be using this thing. You would load the file and you would print the data. So this is one thing in pickle files. And the next will be Excel sheets. So in Excel sheets you will be using the pandas again. So pd.excel file, and this is the file location here again. And again you would be printing print data.sheet name, so it prints you the entire Excel sheet. So I will tell you at the end. So SAS files. So SAS file stands for Statistical Analysis System. So applications of SAS file would be in biostatistics, which is of utmost importance for people studying biotechnology or B-Pharmacy or some agricultural engineering. Multivariate analysis, predictive analytics, business intelligence. So predictive analytics is again in the linear regression and all, where we use certain algorithms to predict future values. For example, let's take there is a heavy rainfall, and based on the previous data, like let's say there is some 50 centimeters of rainfall. So what you would try to predict is like for that 50 centimeters of rainfall, how many number of umbrellas should I be keeping in stock so that I could like increase my business. So those are all the analytics which you would adopt by using the predictive analytics. And also the business intelligence comes like how much you are able to use the data to improve to increase your business. So that is called as the business analytics. So yeah, SAS files. So for importing SAS files you would import pandas, and again this is another package called as SAS7bdat. So the file format for SAS files would be SAS7bdat. So that you can acknowledge them by saying the format. So this will be the format in which the SAS files end with. Again you would be using the context manager while SAS7bdat and as file. So df underscore SAS equal to file. So these are all like something which you need not remember. So what happens is whenever you encounter a file, like you need to open this thing and just you can copy paste the syntax. First and important foremost thing is like you will be mainly handling Excel spreadsheets, you will be handling txt files, and you would be handling CSV files. So it is important if you like remember only those three things. For your sake of understanding, like what happens if you understand, like you should be knowing what and what syntaxes you should follow when you have been encountered with different types of files, right? So for only that sake of convenience, I am explaining this thing. And again, for stata files, so stata is basically a joint word for statistics and data, and it is applied in social sciences research. So and for reading a stata file, it is like basically simple. You can just use like pd.read stata, just how you do that pd.read csv. It is as simple as that. And next, for the hdf5, you will be importing like import the hdf5 stands for hierarchical data format version 5, and it is used for storing large data sets of numerical data, which could be tons of gigs. And here tons of gigs usually means like some like extraordinary amount of gigabytes, like not only gigabytes, they can even scale up to exabytes, like so many gigs of memory it is. So that can be like visualized by using importing h5py. And next is your file name, which is your location here, and that could be done by using the context manager again here, data equal to h5py.file, and just print. You can print the type of data, but what happens is most of the hdf5 data will be stored in a dictionary format. So for that, again in dictionary, if you remember, what you should be trying to do is you should be writing something like, let's say I have given data, right? So I should be doing this thing in order to print my values in hdf5 format. So the data in hdf5 will be in a dictionary type. So again, for printing those all things, you should be using this thing. If you remember, I have told in the previous classes that for accessing a variable, like accessing the key value pairs in a dictionary by using a for loop, you should be writing a syntax like this. Yeah. So next would be the MATLAB files. So MATLAB stands for Matrix Laboratory, and it is an industry standard in engineering and science. So the data is always saved in .mat files. So scipy.io.loadmat, which is used to read mat files, and scipy.io.savemat, which is used to write mat files. So since we are using scipy.io, so this is another special package which you should be using. So you will be import scipy.io, and then you will be giving your file location into a variable called as file, and then you would be giving like mat equal to scipy.io load mat, which is to read a mat file, and again you will be printing it. So yeah, that is how you will be accessing the elements, accessing the information in a mat file. So what's the most important thing here is you need to understand only txt file. So in a txt file, you would be using like a context manager is used with open. This is your location where the txt file resides, and this is just to mean that you only want to read the file with open sample txt as a reading thing, which you want to open it as a file. Print like we have given a file variable here, right? So instead of giving a file variable like this, we have directly written like open this whole thing as a file, and I want to access it by using this thing file.read. So it is a 2-line command, and the next thing would be pd.read csv, and the another thing would be an excel sheet, like how you would read an excel data. So that can be done by using pd.excel file, and just use print data.sheet names, so it prints the entire data present in the excel file. And whatever you try to do before doing any visualization or analysis, you import all the necessary packages, you give your file location into another variable, and you can access that variable by using like you can convert that entire thing, like you have given the location, right? So basing on that location, you can convert that entire thing into a data frame using pd.read csv, and you can know that if you have converted your data set into a data frame or not. You can use like type of data frame So that I have written that you have converted it into a data frame format. And then you can see the shape, like it returns how many rows and how many columns your data frame has been figured out. So that can be done by df.shape, and it has given you 11 columns, right? So that can be known by df.columns, and it gives you all that column label names here. And the next would be the index. So for rows, the index part, the range index is usually a constructor. There is nothing for you to worry about. So starting was 0, which is this one, and the ending 16,5098, and the step is 1. So step means actually the difference between two corresponding rows. So here it started with 0, here it started with 1, so 1 minus 0 is 1. So 1 2 and 2 minus 1 is 1. So that is what here step means here. And yeah, you can directly use either df.head, or if you want to be more uh, programmatic in your approach, so then you can use iloc method. So iloc actually takes indices, right? So df.iloc. So what it means here is I wanted to print all the values till row index 5. So what I have told you in the previous class is that 5 is exclusive. So if you want to print till 4, so you should be giving 5. So if I want to get the fifth row, so I would be giving 6. So then I will be getting the 5. So if I don't want, like if I want from, if I don't want this 0 index, so I want from 1, so I will write 1. So this actually means that you want to print all the columns, like whatever columns are there, you want to print all of them. And the next is df.tail. This is the same thing, and the next would be df.info. So it gives you the information of what the data type of each column is and how many non-null entries are there. So whenever you try to perform any statistical analysis, the main thing you should be knowing is, let's say you have, okay, I'll give you an example. So let's say you have given a values like this. Since it is a list, it will not eventually work out, but I am trying to give you an understanding. So the next I have given, like I have empty values here, and again I have started my values like this. So what happens is when you try to visualize this whole thing in a graph, so what happens is, let's say this would be your x, and there is, just a minute. So let's say this is your x-axis, this is your y-axis, and this is your x-axis, right? So in machine learning, what you will try to do is, based on the all data points, you will try to give up an, like let's say this is my data point, right? So what happens is there will be so many data points like this. So based on all those data points, what I will try to do is I will draw a line which is near to all those data points, like the line which I have been making, like the line which I want to make, the regression line. It is drawn in such a way that most of the data points are present on this line, and like very few are like outside here. So let's say in my previous example, like this would be the amount of rainfall. Okay, so this is the rainfall. I'm sorry, I'm not very comfortable at, so this is my rainfall. So what happens is, as the amount of rainfall is increasing, so this axis will be my number of umbrellas to be sold. So I will just write umbrella okay. So what happens is, as the amount of rainfall increases, So correspondingly, the number of umbrellas I should be selling will also increase, right? So this is a regression line. Like what happens is with varying x-axis, the y-axis is also varying. So let's say this line has been drawn, it's based on this type of data set, like this type of data sets. So this line is drawn taking all these labels into consideration, and we have drawn this line. So what happens is, if there are any missing values, your line will somewhat look like this. Okay, so what happens is, when I try to measure the correspondency, like if I go like this, and at this, let's say at this point, I want to like measure how much of umbrellas I would be selling. So here there is nothing, it would be going somewhat like this. So that's the impact a missing value does. So what you will try to do is, you will replace it with some mean or something, so that you will bridge the gap by yourself, and correspondingly you will try to predict your thing, like what analysis are you doing. So based on that, you will be doing your prediction. So what happens is, for numerical values you can actually do this thing, like you can bridge the gap in between by using some mean, median or mode. But what happens is, for like, let's say I have taken like in this example, so how can we change rows into columns or vice versa? You can't change rows into columns, bro. So the whole point is, so what if I want to, like, this is fixed, like you are having a label name, and for that corresponding label name, these are all the observations. So how can you convert observations here and put label names here? So that doesn't make any sense. What you should know is, these are the label names which you have got, and these are the corresponding observations which were given to you. So you will take these observations into consideration, and based on these observations you will be developing models. So that is, so you should be knowing only till there. So no, there is no transpose or nothing here. See, the whole point is, let's think I put name here and I put this thing here. So what's the use? Like it is not like, we can't like really relate. This is a data set. So a data set contains the label names, and for that label names you are getting these corresponding observations. Okay, so what you will try to do is, you will be taking these label names into considerations, and you would be using these corresponding observations to develop your model. So you should be really understanding only till that point. You will not like transpose. So what you are trying to achieving, like what do you want to do by doing a transpose here? So you won't be doing any transpose or any sort of matrix operations here. You will not be doing inverse as well. So in future, if you wanted to ask me, what you will try to do is, you will just be importing your data set. You will be understanding what all columns and what all stuff are there in your data set. You will be seeing if there are any null values, and you would be understanding in future sessions that how you can actually like perform certain operations, like how you can replace those null values with mean, median. We actually don't use mode, so there is no point of talking about mode. So you will be using mean mostly, and in advanced levels of machine learning we will be using imputer. So that is another way by which it replaces the missing values by mean. So that all things you will be understanding in the like next 14th or 15th class. So yeah, what you will try to do is, you will just import your data frame. You will be giving your path where the data frame is. You will be visualizing it into a data frame by using pd.read.csv. You will check whether if it is in a data frame format or not. So that can be done by using type of data frame. So once you have done all the data frame setting and everything, so then you will be understanding how your data frame is. You will be understanding how your data frame was, like its shape. So you can use df.shape. It have given you this many number of rows and this many number of columns, and what column names are there. So that can be known by using df.columns. And for the indices, this part, df.index. And the next is like you can't visualize, like you can visualize, let's say I just print df. so it brings me the entire thing. Okay, so there is no like the little bit what you should be trying to understand here is you should be able to understand your data bit by bit. Like you go from a very small part and gradually increase your level of understanding, and as a whole you can derive a basic understanding of the entire data set. So the whole thing lies like you understand your data set bit by bit, and at the end of all the analysis you club all those conclusions which you have made, and on that conclusion you develop a new model or something. So that's how it goes. But you can't really transpose it, Balaji. Like if you keep name here, if you keep platform here, and if you keep the index here, so what we are trying to achieve is nothing. So given as it is, you just need to understand that these are the label names, and for the label names these are the corresponding observations, and using those observations you should be predicting your analysis, you should be developing your own model. And you should be like how you draw margins for your answer scripts in colleges, that same way you should be doing all these things, so that it gives you a basic understanding about your data set. And in the later classes we will be understanding like how we should be dropping the null values, how we can replace the null values, how we can drop a entire row. Like if I want to drop the 16,594th index row, so how we can do that, how we can add a new column into our data set. So we will be learning all those in the next class.